Okay, the answer for number 1 is C. All right, so I would do u substitution, and I would make my u 3x, which would make my du 3dx. So then if we look at what we have here, we have the cosine of 3x dx. Then what I need is I need a 3 here to match that 3dx, which means I need a 1/3 out here. So then that would be 1/3 the integral of cosine u du. And the integral of cosine is sine u plus c, which is 1/3 sine of 3x plus c. And there's your answer, choice C. Okay, number 2, I believe the answer is choice D. So you can do this 2 ways. I kind of prefer factoring if I can. Well, actually, wait, let me back up. You really should plug in the 0 here into both parts of the numerator as well as both parts of the denominator, but when you do that, you end up getting 0 over 0. So when that happens, what you want to do is you want to factor the numerator, okay, which is going to give me 2x cubed, and then x cubed plus 3. And then we're going to do the same thing in the denominator. And the only thing I can take out there is x cubed, and then I'm going to be left with 4x squared plus 3. Okay, now I can cancel these terms because they are like terms. And then technically what I really have here is the limit as x approaches 0. All right, so I still have that 2 all the way in front, but when I plug in 0 here and here, those terms disappear, okay, but I still have these guys right here, right? So that's going to leave me with 2 times 3 in the numerator, and in the denominator I have 3. So that's 6 over 3, which is 2, and there's your answer. The answer for number 3 is C. So when it says that something is continuous, we're going to take the top part of that piecewise function, and we're going to set it equal to the bottom part of the piecewise function, and we're just going to plug in 2. So that'll give me 4 minus 6 plus 9 equals 2k plus 1. We're going to get 7 over here equals 2k plus 1. So we have 2k equals 6, and then you can see that k would be 3. All right, the answer is choice B. So I would start by rewriting my original function. So put the cube on the outside because I'm going to need to take the derivative and I'm going to need to do chain rule. So the 3 drops down in front. Let's keep everything on the inside the same for right now. Raise that to the second power. Now you need to take the derivative of the inside. Well, the derivative of cosine is negative sine, okay, now listen, u du. So in other words, the derivative of this. So I'm going to have a 4 there. Okay? So when I multiply this 3 times that negative 1 times that 4, that's where that negative in choice B, negative 12 comes from in choice B. Okay? And then I've got the cosine of 4x. That quantity is going to be squared. And then I just have the sine of 4x. Remember, the negative went all the way in front. And there's your answer, choice B. Okay, number 5, the answer is choice C. So they want a minimum. You should know whenever you see the word minimum, maximum, increasing, decreasing, that you are going to want to take the derivative and set it equal to 0. So I'm going to get 6x squared minus 6x minus 12. I'm going to factor out a 6, and that's going to give me x squared minus x minus 2, right? And then when I factor that, that's going to be x minus 2 and x plus 1. Now I want to figure out maxes or mins, so I'm going to do a sign chart. and I'm going to put the zeros on there, which is -1 and 2. Those are my critical points. And I am going to do my signs, so plus, minus, plus. Now I'm looking for a minimum. Okay, so just remember, a minimum occurs when the derivative goes from negative to positive, because that means that the function is decreasing, then increasing. Okay, so that's why the answer is choice C. All right, answer is choice B. Okay, so if we want to find the equation of a tangent line, remember that we use y minus y1 equals m times x minus x1. They gave me the x value. If I want to find the y value, I'm going to be plugging it back into the original function. So if I want to find f of 1, I'm just going to do 2 times 1 minus 1, which is going to be 1, and then multiply it by 1 plus 1, which is going to be 2. So here is your y2, your y1, and over here, this is your x1. Okay, so really now all we need is our slope, and then we can write the equation of the tangent line, which would require us to take the derivative. So I'm going to do product rule. So I'm going to keep the first one, which is 2x minus 1, that quantity raised to the first, times the derivative of that second set of parentheses, which is really just a 1. I'm not going to write it. Then we have plus, and then we're going to write the second term times the derivative of the first, which is 5 times 2x minus 1, that quantity to the fourth, and then multiply by the derivative of the inside, which is 2. Okay? And then here, really all I'm doing is I'm plugging in. You can simplify it, but it's really not necessary because you're going to plug in an x value of 1. Okay, so in that first parentheses there, I am going to get 1 plus 2, and that 2 is going to get multiplied by that 5, and then times 1, and then times 2. So that's 1 plus 20, right? Okay, so f prime of 1 is 21. So your equation is y minus 2 equals 21 times x minus 1. Okay, but that's not the form that your equation is in choice A, B, C, D, and E. So I'm going to get the y by itself, and I'm going to distribute the 21 at the same time. So I'm going to write y equals, let me distribute that 21. So that's going to give me 21x minus 21, and then I'm moving that 2 over, so plus 2, and there's that 19, that negative 19, which is choice B. Alrighty, 7, the answer is choice A. Now you're going to have to do u substitution here. I would make my u the radical x, which if you're okay with that, I'm just going to make that x to the 1/2 power, which in turn would say that the derivative is 1/2 x to the negative 1/2 power. Well, another way to write that is 1 over 2 radical x. And let's not forget the dx. Okay? All right. So be a little careful here. If you look at what I have right here, that is equivalent to this radical x on the bottom with this dx. Look at what I'm pointing at right here. It's the same as this. The only difference is I'm missing the 2. So I really need a 2 down here. Okay, so if I need a 2 down there, let me squeeze that in there. There's a 2, right? Then that must mean, now that 2 is in the denominator. So really, if you want to think about it, this is equivalent really to 1/2, right? 1/2, 1/2, which means I need a 2 then on the outside. So I need a whole number 2 on the outside. So then what that gives me is 2 times the integral of e to the u du. And you should remember when we integrate in e to the u, it's just e to the u plus c, but don't forget the 2 in front. And now I just plug my u back in, which is 2e to the x to the 1/2 power, which is really a radical x. And there's your answer of A. All right, number 8, the answer is D. Now they're asking you to do a trapezoidal approximation, and they want 3 subintervals. So here's your first one, there's your second, and there's your third. Remember a trapezoid? 1/2 height, base 1 plus base 2. Now remember, your heights really are just the distance between these intervals right here. And each of those distances has a width of 2, a width of 2, and a width of 2. Okay? So your height is, for every single trapezoid, is going to be a 2. So if I'm starting that off, I have 1/2 of 2, and then really your bases, your base 1 and your base 2, are just going to be this height and this height for the first interval. Then for the second interval, it's going to be k and 8. And then for the third interval, it's going to be 8 and 12. Okay, so I'm going to write that down. So for the first interval, again, remember we add them. So for the first interval, it's going to be 4 and k. The second one is going to be k and 8. And the third one is going to be 8 and 12. Plus. There we go. And they tell you that this is all going to be equal to 52. Right here. Okay, well, 1/2 of 2, that's gone. So I'm just going to simplify what I have inside. So I'm going to do 4 plus 8 plus 8 plus 12. And when I do that, I get 32 plus, now I have k and another k, so that's 2k equals 52. So 2k is equal to 20, and k is equal to 10. There you go. Number 9, the answer is C. So they're giving you velocity, and then they're telling you the particle is at position of 7 at time 1. So what that really basically means is at time 1, the position is 7. And then if you read the rest of the question, it's asking what is the position when t is 2. So it wants that. Okay, well, I know position is the integral of the velocity, so I'm going to start by integrating the 4 minus 6t squared. Okay, dt. So when I integrate that, I get 4t minus, and then 4t minus, let's make that look like a minus, 2t cubed. Don't forget, though, we have to write plus c. So this is my position equation. Okay, now they gave me this value up here, so I'm going to throw that in there so that I can solve for my c. So I'm going to write 7 equals, and I'm going to plug in 1 for every t value, right? So I'm going to have a 1 here, which is going to make this 4, a 1 here, which is going to make that 2. Okay, so it's really 4 minus 2, and 4 minus 2 plus c. So that's going to be 2, and when I bring that over, that will give me 5 as your c. So your final position equation is going to be 4t minus 2t cubed plus 5. And then lastly, what they want you to do is they want you to plug in, if we look right here, they're asking you to plug in 2 everywhere you see a t. Okay? And when I do that, and I plug in 2, I'm going to get 8 here. Here I'm going to get minus 16. And then I'm going to add 5. And that's going to give me negative 3 as my answer. Okay, so the answer for number 10 is D. Now they're talking about horizontal and vertical asymptotes. So I'm going to start with horizontal asymptote. It doesn't really matter which one you start with, but horizontal asymptote, hopefully you remember, we should be doing end behavior. So when I do that, I'm going to get ax squared over x squared. And that's going to cancel out because those are common factors. So really then, all I'm left with is a equals, and now let's look at what the horizontal asymptote is. The horizontal asymptote is this value right here, which is 3. So I would normally just set this equal to 3, but since those factors cancel out, I'm going to set this equal to 3, and there's my a value. So that eliminates these top 3 choices right there. Now, when I want to do vertical asymptote, we set the denominator equal to 0. So we set the denominator equal to 0. And if you look at what they gave us, we know that the vertical asymptote is at x equals 2, okay? I am going to just write x squared equals negative b, and then when I set, I know that x is 2, hold on a second, let me point, right? X here is 2, so I'm going to put in a 2 here, okay? And when I do that, I'm going to get 4, because 2 squared is 4, equals negative b, so then b has to be negative 4, and the answer is choice D. Number 11, the answer is choice B. They're asking for the slope. So I have the function, I am going to take the derivative. I'm going to do quotient rules. So I've got y prime equals low d high. Now, derivative of e to the x, or e to the negative x, would be e to the negative x, but then you have to take the derivative of that negative x. So that's going to be negative e to the negative x. So there's low d high minus high d low, which is really just 1, all over low, that quantity squared. Okay, now we're going to be plugging in, no need to simplify right at this moment. I'm just going to plug in 1 because it says that x equals 1. So then my y prime is going to be 1 plus 1, which is going to be 2. And for right now, I'm going to leave this as negative e to the negative first power. I'll deal with that later. And then this is going to be minus e to the negative first power. And all of that is going to be over 1 plus 1 squared, which is going to be 4. Okay, so you should see that this is negative 2e to the negative first, and this is negative 1e to the negative first. Those are like terms. So I'm going to combine those over here. Okay, and I am going to get negative 3e to the negative first power, and that whole thing is over 4, which is the same as negative 3 over e. Okay, because remember, when you have a negative exponent, you bring it down to the denominator. Over 4, technically over 1, right? So I'm going to flip here, because I've got a complex fraction. So I'm going to multiply both the top and the bottom by the reciprocal of that denominator. And then you can see that when I do that, I am going to end up with negative 3 in the numerator and 4e in the denominator. Okay, and there is your answer, choice B. Alrighty, number 12. 12 is choice D. Okay, so will they give us the derivative? And notice they give us something about the function, which means then to get from here to here, I'm going to need to integrate. So I would start by integrating my f prime, which is 2 over x dx, but I don't like that 2. What I'm going to do, remember any constants, we can always bring them out in front of the integral. And the reason why I'm doing that is now if you look at this, I've got 1 over x dx, and hopefully you see that that's an ln. So the integral of that would be 2 times the ln of x plus c. Okay, so there's your f of x. Now, going back to what we have right here, I'm going to plug in radical e for my x value. I'm going to set it equal to 5. So I'm going to have 2 times the ln. Now that's radical x. I'm just going to make that x to the 1/2, and you'll see why in just a second. Plus c, and again, we're setting y equal to 5. Now the reason why I made this x to the 1/2 as opposed to radical x is because, oops, hold on one second. I was supposed to put an e in here, wasn't I? Okay, I'm going to put that in red just so you can see that that really is supposed to be an e. So getting back to what I was saying, the reason why I left this as 1/2 is because I know an ln and an e are going to cancel each other out. And then really all I'm going to have is 2 times that 1/2. Okay, and when I do 2 times that 1/2, obviously I'm going to get 1. So this is really just going to be 1 plus c equals 5. So my c is 4. Okay, and I'm going to just bring this back around over here because I've got some room here. All right, so let me just go back. So now I'm going to just rewrite my function. Now that I know what my c is, okay, f of x is 2 times the ln of x plus 4, right? And then lastly, if you look right up here, they want to know what f of e is. So everywhere I see an x, I'm plugging in e. So 2 times the ln of e plus 4. Well, like on the last one, the ln and the e are going to cancel each other out. So that's just going to be 2 plus 4, which is 6. And there's your answer. All right, 13, the answer choice is B. I would just double distribute x cubed plus 1 times x cubed plus 1. Okay, so when you do that, you're going to get x to the 6th plus 2x cubed plus 1 dx, and then you're just going to integrate that. So that's going to be 1/7 times x to the 7th plus 1/2 x to the 4th, that should be an x, and then plus x. And again, we don't have bounds here, so we're going to put a plus c at the end, and there's your answer. Okay, 14, the answer is choice A. Okay, 14 is the definition of a derivative. I know this because it's a limit. It's as h approaches 0, and we always have a difference up here. Usually, well, most often, it will have an h here and an h here. So I know this is the definition of the derivative. So what it's asking me to do, essentially, is to take the derivative of a certain function. Now we have to find that function. So that function will always be whatever's to the left of the minus sign, which would be here. But what we're going to do is we're just going to kind of like mentally get rid of that h there. Okay, so let me just show you. So then really, they're telling you that f of x is really then just equal to e to the second. And again, it's definition of derivative, so we're going to take the derivative of that. Well, you should know that e is a constant. It's 2.718 blah, blah, blah. And even if we square it, it's still a constant. So if we take the derivative of any constant, we should always get 0. For 15, the answer is choice E. Now, be very careful with this one. Remember that these slope fields represent the actual function. So when I kind of look at this, I sort of say, oh, okay, comes like this, kind of levels out like that, and it kind of comes back down like that. So what you have to be careful of is these choices that we have to compare to. The graphs of these, or one of these, should be similar to the graph of this, okay? So like for the example, this is not the answer because that's a downward pointing parabola. This is not a downward pointing parabola because we've got these tails at the end. So it's definitely not going to be choice B, okay? C, same thing. That's not an e to the x graph. So that's not it either. And D, also not it. It's a square root. Okay, so I would kind of look at the fact that, well, maybe that could be cosine-ish, but it also could be this 1 over 1 plus x squared, okay? But here's the deal. Remember that all of these slopes that you have up here are slopes for the derivative, right? And what is the derivative of your cosine? And those slopes don't match the picture of the sine curve, okay? And thus then why the answer is choice E. Okay, so the answer for 16 is choice E. Now if you look, they gave you the graph of the derivative, or the equation of the derivative. Remember an absolute value though, and especially if the number is inside parentheses, we've got a horizontal shift in the opposite direction of the sign. So this is my picture for f prime. If I was doing a sign chart then for f prime, I'm going to just look for where it's above and below, which, well, it's always above. So if the derivative is always positive then your function's always got to be increasing. Okay, so if your function is always increasing, it can't be this one, or this one, or this one. Okay, so you're down to D and E. But here's the deal. The function is always going to be increasing here. Okay, but this one here, so you say, okay, well that's decreasing, and oh wait, there's a point here, so that means it wouldn't exist. But what wouldn't exist is the second derivative at that point. So this is really a picture for the second derivative, or f double prime. Okay, since your derivative is continuous, meaning like no breaks like we have here, since your derivative is continuous, your function will be as well, and that's why it's e. Whereas if they were asking, hey, what's the graph of the second derivative, then we could have a conversation and say it might be something along those lines. Okay? All right, so 17 is choice D. Whoops, I meant to circle choice D. There we go. First, you have to figure out what this picture looks like. Okay, so what I did first was I wanted to see where this, I knew it was an upside down parabola, but I needed to know where it hit the x-axis. So I factored out an x, and then I got 1 minus 2x equals 0. And then from there, I saw that I would have an intersection or hitting the x-axis at x equals 0 and also at x equals 1/2. Okay, so then I knew my picture would be an upside down parabola like this, and this is at 1/2 and this is at 0. Okay, and then I have the line y equals negative 5x, and that's going to go through the origin, and it has a slope of negative 5, so it's going to be kind of like that. Okay, now we want the area enclosed between those two graphs, so we're looking for this space in here. So I know that my left bound is 0, 0, but I'm not really quite sure where this is. So the only way I'm going to find out where they meet is to set these two equal to each other. Okay? All right, so I'm going to set them equal to each other, and I'm going to get x minus 2x squared, set that equal to negative 5x. I'm going to bring everything over onto one side. I'm going to move everything over to the right side, and so then that will give me 2x squared minus 6x equals 0. And then I'm going to factor out a 2x, and I'm going to get x minus 3. And then I can see that they are intersecting at an x value of 0 and also an x value of 3. Okay? Now, I'm going to just bring down the rest of my work down here. Okay? Alrighty, so now I know I need to find the area between the two curves, so I know that's an integral. I know I'm going from 0 to 3. And then it's going to be the top curve, which is x minus 2x squared, minus the bottom curve, which is negative 5x, which is really going to turn that into a plus. Okay, and I'm going to combine like terms before I go ahead and I integrate. So that's going to give me negative 2x squared, which should be a negative, and I am going to get plus 6x dx. Alrighty. So when I integrate that, I'm going to get negative 2/3 x cubed plus 3x squared, and I'm evaluating from 0 to 3. Okay, so basically, really, I'm only plugging in the 3 because when I plug in 0, I am going to get nothing. So I'm going to have negative 2/3 times 3 squared, which is 27. And then over here, I'm going to have plus 27, which ends up being negative 18 plus 27, which is 9. And that's choice D. All right, let's look at number 18. So 18 gives you the derivative, but it gives you something about the function. So I know that the function contains the point 1 comma 4. That's what this is basically saying there, right? So if my function, if my derivative is 2x plus 1, then I can find my actual function, or I should say I can find the slope rather, by plugging in the point 1 comma 4. Okay, so I'm going to plug in 1 here, and so f prime of 1 is going to be 2 times 1 plus 1, which is 3. So here's your slope. Okay, so they ask you to find an approximation by using the tangent line. So I'm just going to find the tangent line first. So I know the tangent line is y minus 4 equals 3 times x minus 1. So now they want me to find an approximation for f of 1.2. Remember that 1.2 is an x value. So y minus 4 equals 3 times 1.2 minus 1. Okay, let me bring this up over here. I'm going to get the y by itself. Now this is an approximation, so I'm going to use the approximate symbol. And I know that 1.2 minus 1 here is just going to be 0.2 times that 3 is 0.6. Okay, so I'm going to have 0.6, and then I'm adding that 4 over. So my approximation would be 4.6, and that is choice D. 19 is choice A. So they talk about concavity. I have a function, so I'm going to take a second derivative. So first, let's take the first derivative. So f prime of x is going to equal 3x squared. Oh my goodness, my pen doesn't seem to want to work here. That's a squared. 3x squared minus 12x, right? And then my f double prime is going to be 6x minus 12. Let's set that equal to 0. Take out a 6. I've got x minus 2. So I see that I have a critical point at positive 2 on the second derivative. I'm going to do my sign chart, and I should get negative, then positive. And it's just asking for where it's concave up, so that would be when x is greater than 2. All right, number 20. Number 20, the answer is C. Okay, so they give you g of x. They give you that f of x is equal to g prime, and then they want you to integrate, right here, f of x from 1 to 3. Well, isn't f of x the same as g prime? Okay, that's what they said right here. Now there's a reason why I am going to do that, because when I have an integral and a derivative, don't they cancel each other out? Okay, so then what I'm really going to do is I can cancel the prime, oops, I thought that was my pen. I can cancel the prime out with the integral, okay, and then basically what I'm going to essentially have is g, and I'm going to evaluate it from 1 to 3. So I'm going to take my x squared minus 3x plus 4, and I'm going to plug in the 3 first, and then I'm going to plug in the 1, and I'm going to subtract those two. All right, so I'm going to do the 3 first. So 3 squared is going to be 9 minus 3 times 3, which is 9 plus 4, right? Minus, and now let me plug in the 1. So that's going to give me 1 minus 3 plus 4. Okay, well, in the parentheses on the left, I have 4. And in the parentheses on the right, I have 2. And if you work that out, that is choice 2. I mean, which is 2, which is choice C. 21, the answer is choice C. Now, you can read through this, and you should have read through all of this. I am looking at what it's asking for. What is the maximum value of f? When I see that word maximum, I think derivative. So I have a derivative picture. I'm going to do a derivative sign chart. So if I do a derivative sign chart from a derivative picture, I just look for above and below. Now, I don't exactly know where these zeros are, but I know that if I look before this 0, the derivative is above the x-axis, then below, and then above. So when I'm doing my signs, then I'm going to have plus, minus, plus. Now, the question is asking for the maximum, and I have a maximum right here. Okay, so I will not be looking down this way because the maximum doesn't occur there. The maximum occurs from here to here. The other key word is this word value. So they really want the total amount. Well, I'm having a maximum right here. So the amount or the value would be 20. But notice they gave you this little bit right here. So what that's saying is It's kind of like if you're running a race, right? You would start at the start line, and then, so you're starting at like ground zero, so to speak, and then you start running. But this is saying at time zero, you're not starting at the start line. You're starting with like 2 extra steps ahead of everybody else, okay? So you have 20 plus these 2 extra steps, so to speak, okay? So you've got that 2 plus that 22. I'm sorry, plus that 20, which gives us 22. Okay? All right. 22. The answer is choice A. 1 only. Okay, so let's look at that one. If you notice, all 3 of these are talking about maximums and minimums. So I'm going back to what I did on 21. I'm going to do a sign chart for the derivative because max and min means derivative. Okay, well, if we look at the factors that they gave me here, then I know my zeros are going to be 2, 3, and 4. And then I'm going to plug in numbers and formulate a sign chart. So when I do that, I picked like 0. Here you could pick 2.5, 3.5, and I don't know, anything you want bigger than 4. And that's what I end up getting. Okay, so I've got a maximum here. 3 is nothing, there's no sign change. And 4 is a minimum. And then you can see then when you go back and you look at your Roman numeral 1, 2, and 3, the only one that makes sense is Roman numeral 1, which is choice A. 23 is D. Please make sure that you're reading this and they want to know which one is false. Start with the fact that what you have here is you have the function. Okay, so let's make sure that we have that clear in our minds. And it says, which of the following statements is false? Okay, so let's start with choice A here. This obviously then has to be true, right? Well, it's saying the limit as x approaches 0 of f of x minus f of 0. So what I did was I was like, okay, well, let me look and see what f of 0 is because this is the graph of f, right? So f of 0 right there is 0, isn't it? So I replaced this with 0, which then really basically means that you have the limit as x approaches 0 of f of x equals 0, because I made this disappear because I know it's 0. Well, let's look at the picture. Is the function, as we approach 0, coming from the left and the right, remember, is it going towards 0? And yes, it is. So that's true, so that can't be the answer. Okay. Choice B is definition of derivative. Hate to tell you, but here we go. This is definition of the derivative. Okay, and this is saying the derivative at x equals 0 would be 0. And that is true. This is the function, okay? But look, we have a horizontal tangent in the function, which means the derivative is equal to 0. So choice B is true. Again, that's not what we're looking for. Okay, now choice C. This one's a little bit trickier. I had to think about this one. They tell you it's an even function. So do you agree that whatever number we have here, this would be the same number? So like, let me give you an example. Okay, so let's say we put a number in here. Let's say we put like 3. So f of 3 is up here, right? So then this would be f of negative 3. Isn't it the same thing? Isn't f of 3 3 and f of negative 3 also 3? These have the same y values. So in other words, if I put a 3 here and then a 3 here and I subtract them, wouldn't I get 0? Which is that, which is true. So that's not it. Okay? All right. Then we get to choice D. This is definition of a derivative, just like choice B is. But this is saying the derivative at x equals 2. So let's look at the derivative at x equals 2. Well, this is the function. So the derivative would be the slope. And if you look at this slope at x equals 2, okay, it would say that it would be 1, which this slope is 1. However, look at the difference here from choice B. Definition of derivative will only have an x down in the bottom. Sometimes it's an h or a different letter, but one singular letter as opposed to these two, okay? So that makes this false, which then would be choice D. Now, also just quickly, this is referring to a derivative, but at x equals 3, and it does not exist. We would not have a derivative because we have a peak or a cusp in the function. 24 is choice D. Okay, so they say that the radius of the circle is increasing. This is the important part right here. It says at a certain instant, so at one point in time, the rate of increase of the area is numerically equal to twice the rate of increase of the circumference. Rate of increase of anything is always derivative. So what I did was I started with A equals pi r squared, which is the area of the circle, and then I found the derivative, which is dA dt, equals 2 pi r dr dt. Then I would do the same thing with the circumference, which is 2 pi r. And if I take the derivative of that, dc dt would equal 2 pi dr dt. Now, what this was saying was there's a certain instance when the area of the circle is equal to the rate of increase, of the area of the circle, so that would be this. This would be equal to twice this. Okay? All right, so let me just write that for you. So the rate of increase of the area, which is 2 pi r dr dt, is going to equal twice the rate of increase of the circumference, which would be 2 pi dr dt. And now what I'm going to do is I'm going to cancel out some things that are equivalent on both sides. So for example, I've got a 2 here. I'm going to get rid of the 2 there. I have a pi here. I'm going to get rid of the pi there. There's a dr dt here. I'm going to get rid of the dr dt there. So essentially, I'm just dividing by any common terms. And then, so if I look at what's left on the left side, I just have r, and what's left on the right side is 2, and read the question. That's what it's asking for. What is the radius? Alrighty, 25 is choice A. So you need to do implicit differentiation. So just make sure that you're going to do product rule here. So product rule would be x squared dy dx plus y times 2x minus 3 equals 3y squared dy dx. And then we know that the derivative of a constant is 0, so that just disappears. Okay, I am going to bring my dy dx's to the left side. It doesn't matter what you do, but I'm going to factor them out at the same time. So the x squared staying on the left, but my 3y squared over here is coming over to the right, so that's going to be minus 3y squared. And then I'm going to bring those other terms to the right-hand side. So that negative 3 is going to become positive, and then I'm going to have minus 2xy. And then I am just going to divide out the x squared minus 3y squared from both sides, and there's my dy dx. Okay? Now they wanted us to go a step further though, and they want you to evaluate this at the point negative 1, comma 2. So I'm going to plug in negative 1 everywhere I see an x, and I am going to plug in 2 everywhere I see a y. Okay, so in my numerator, I'm going to end up with 3 plus 4, and in the denominator, I'm going to have 1 minus 12. That's going to be 7 over negative 11. For number 26, the answer is choice C. So what I would probably start by doing is they want to know which of the following is true. if we want decreasing or increasing, I would always look at the first derivative. So I'm going to look right here. And remember, we want to see, if we want to do a sign chart, we want to see where this first derivative is equal to 0, which would mean where's the numerator equal to 0. And we also want to see where the first derivative doesn't exist, which means where's the denominator equal to 0. So let's start by looking at the numerator equaling 0. What would make this 0 in the numerator? And hopefully you'll say that if x is 1, because we know that the ln of 1 is 0. Okay, so when I start to do my first derivative sign chart then, I know that I'm going to have a 1 on it. Okay, all right, well, then let's look at the other thing that I said. Where does the denominator equal 0? Obviously, if we plug in x equals 0. So if we plug in x equals 0, we would get the denominator equal to 0. So there is my other critical point on my first derivative sign chart. Okay, so now what I'm going to do is I'm just going to plug in numbers. So if I plug in, for example, something over here, that would be a negative number. Well, I can't have the ln of a negative number. It doesn't exist. So over here, we're not going to have a sign at all. We're just going to ignore it. But in here, I could put in like 1/2. Now, honestly, I don't know what the ln of 1/2 is, but I do know that the ln of 1/2 will be some kind of a positive number. Okay, and then over 1/2 would also make that a positive number. So then we can put a plus sign right there. And then the ln of, let's just say I want to plug in a 2. The ln of 2, again, not really sure what it is, but I do know it's positive. Over 2 would still keep that positive. And there's our sign chart for the first derivative. Okay, which means the function's always increasing. Okay, so if the function is always increasing, then we know it can't be choice A and we know it can't be choice B. Now I'm going to do the same thing with the second derivative sign chart. Okay, so I'm going to see where the numerator is equal to 0 and where the denominator is equal to 0. Well, obviously, the denominator is equal to 0 when we have 0. So let's just throw that on there right now because that'll be an easy one. Oops. Okay, 0. Alrighty, now let's look at the numerator equaling 0. So the only way I'm going to get 0 up here is if this ln of x is a 1, because 1 minus 1 would give us 0. So what value could I put in for x that when I take its ln, I will get a 1? And hopefully you'll see that that's e. The ln of e is 1 because the ln and the e are inverses of each other. They cancel each other out and they become a 1. Okay. All right, now remember e is roughly 2.718, so on and so on. So if we do a sign chart here, again, we're going to have to come up with the same issue that we had over here with negatives. Okay, we can't have a negative ln. It doesn't exist. Or I should say the ln of a negative number. So I'm going to leave that alone. Now we know this is 2.718, so we can plug in a 1 here. And I know that the ln of 1 is 0. So I've got 1 minus 0, so this is just a 1, over 1 squared, which is a positive number. Okay, next what I'm going to do is I'm going to plug in something larger, like 3, because again, that's 2.718. So if I plug in 3, I know, I know that the ln of 3 is something positive, okay? And I know that it is going to be something, hold on one second. It will be something bigger than 1, slightly, but it will be something bigger than 1. So then I have 1 minus something bigger than 1. So this is going to be a negative here over a positive, which would give us a negative down here. Okay, so I'm going to put a negative in here. So if we look at what the following 3 answer choices are saying, all of these are saying that we are increasing for x greater than 1, which is true. However, this one is only increasing from 0 to e. Well, e is not on our first derivative sign chart here, so we can just cross that answer choice out. So that's not going to be it. And then we are looking at really just the concavity. So let's see what's happening here. So concave down when x is greater than e, or concave up when x is greater than e. And then we can see that it's concave down, and that's why it's choice C. Okay, for 27, the answer is E. Oops, don't have my marker on there. The answer is choice E. Okay, so they want f prime here, and so that would mean that I'm going to take this and take its derivative, but if I do that to one side, I do it to the other. Now remember, what that's going to do is that's going to cancel out the integral with the derivative. And also remember that when we have the bottom bound as a constant, all we're going to do is take this top bound and plug it in wherever we see a t. Okay, so I'm going to do exactly that, and I am going to end up with 2x. That quantity is going to be squared minus 2x, and that is all going to be underneath a square root. However, do not forget that the other thing you're supposed to do is when this top bound, when we plug it in for our values of t, if we can take the derivative of this, which we can, we get 2, we have to multiply our answer by that 2. So I'm going to put a 2 out front here. Okay? All right. And then now really all we're doing is, if you read the question, it wants f prime of 2. So I am going to plug in, let me get my pointer, 2 times 2, which is 4. So this is really 4 squared, right? So that's going to be 4 squared, which we know is 16, minus, and then again here, they want at 2, so I am going to plug in a 2 there, which would give me a 4. So underneath my radical, I have 12. There's your answer. All right, so for 28, the answer is choice E. So what I did over here on the right is I just rewrote this with the denominator, whoops, actually I didn't, with the denominator of 1, and here's why. Because this is the setup that we are used to, and we have a u over an a. So I just wanted you to see that technically the u is going to be 5x, and the a will be a 1. If there's nothing written underneath, then we can assume that that's going to be a 1. Okay? All right, so then from there, let me just start with, remember how we usually write a squared equals a equals, and then we write u squared equals u equals and du equals. Okay, well, we aren't given the a squared, we're actually given the a, we know it's 1, and we're not given the u squared, we're given the u, which we know is 5x, but we can go backwards. So obviously a squared has to be 1, and u squared would actually be 25, I'm taking the square of 5x, x squared. And then if I'm going down, if u is 5x, then du will be 5 dx. Okay, so the rule is that we had du over the square root of a squared minus u squared. So I'm trying to make everything that I have over here match these answer choices. So I should know that it's not going to be choice A or B because those are tan inverses, right? Because there's no radical and there's a plus sign in the denominator. Okay, all right, so my du I know is 5, so that's going up here, and then my a squared is 1 minus my u squared, which is 25x squared. There you go. All right, so we are on to onto calculator questions. So 76, you can use your calculator. I would highly suggest you use your calculator, and there is your answer, choice C. Okay, so they give you the velocity and they want the acceleration at time equals 6. So pretty straightforward kind of question. You're going to put the velocity in your y1. Okay, if you need to do that to check it, go ahead and do that right now and then pause me and come back. Now, once you do that, I will go to your home screen. Okay, so get out of your y equals, go to your home screen, and you're going to hit Math 8, which is your n deriv, right? So Math 8, and all you're going to do is n deriv, because remember, acceleration is the derivative of velocity, and you're going to evaluate it at time 6, and you will get 29.453. Okay, number 77. The answer is D, which is 35. Okay, so you see that they give you 3 different integrals, right? And I am going to focus on that last one. So it says the integral from 0 to 5 of 3 plus 2 times f of x dx. Okay, what I'm going to do is I'm going to take that and I'm going to split that up, because we can always do that with the integrals. So I'm going to put the constant in 1, and then just remember also, if we have a 2 associated with an integral, in this case right in front of the f of x, I can take that 2, it's a constant, bring that outside, right? And oh, I'm sorry, this should be from 0 to 5. My apologies there, 0 to 5. And this is also going to be from 0 to 5 of f of x dx. Now there's a reason why I did this, and it'll make sense hopefully in a minute. So I'm just splitting them up. Nothing else has really changed. Okay, so on the left side here, I'm going to integrate 3, which would give me 3x, right? And then I am going to evaluate that from 0 to 5. Okay, then over here, I'm going to have the 2. Now, here is where the other 2 integrals come in, because they didn't give us a value of f of x if we integrated from 0 to 5. However, they gave us 2 f of x integrals, and they were split up, one from 0 to 3 and the other one from 3 to 5. So that's how I'm going to work this one. Okay, so I am going to go from 0 to 3 of f of x dx. Okay, and then I'm going to add to it the other integral from 3 to 5 of f of x dx. Okay, just like that. All right, because they gave us those values. Now let's go back over here to the far left. Okay, so the reason why I pulled this out was it really didn't have anything to do with either of these integrals. And this is just a constant that's easy enough to integrate on our own. Now we're going to plug in 5. And then when we do plug in 0, you're going to see that obviously we're going to get 0 there. So I'm just going to skip that part right there altogether. So I'm going to do 3 times 5, which is 15, plus 2. Okay, now if we look at this, go up to the top of the problem, and you'll see that that is 6 plus, and then we look at this, and if you go to the top, you'll see that that is 4. And the rest is really pretty easy. So we've got 15 plus 2 times 10, so that will give us 35, which was choice D. Okay, so 78, the answer choice is E. Now, this is obviously a reading question. They're telling you that h is a differentiable function, so we know the derivative exists. And it gives the temperature in degrees Celsius at the Arctic weather station. Which of the following is the best interpretation of h prime? Well, if h represents temperature, then h prime should have to do with some kind of a rate. Okay, and A and B do not have to do with the rate, so I'm just going to cancel those out as options. Now, because they're saying at time 24, so we should be looking at something that's talking about the 24th hour. So I would cross out choice D, because that says during the first day, whereas if you look at C, it says at the 24th hour, the 24th hour. Okay. However, the difference between C and E is that C says the average rate, and this one just says the rate. Okay, average rate of change. Remember, we've talked about like mean value theorem. It doesn't say anything. There's no wording in the actual question that has to do with average rate of change. It just is going from a temperature to a derivative. So that would be a rate, not an average rate. Okay. All right. Let us look at the next question. So we are looking at 79. Okay, 79, the answer is choice, whoops, my marker's not on, it's choice A. Okay, so at time 0, our tank contains that many gallons of water, and then for the next 6 minutes, water is flowing out of the tank at a certain rate. Okay, so rate, and then now we are going to how many. Okay, so rate to how many. I'm going to rate to how many. That's definitely an integral. Okay, all right, so let's just kind of focus in on this scenario a little bit more. So we're starting with 81.637 gallons. That's what we're starting with. Now water is going to be leaking out. So we're going to be subtracting however much water has leaked out from time 0 to time 6. And the amount of water that will have leaked out from time 0 to time 6 will be the integral of the 9 sine of radical t plus 1 dt. Okay, because what this represents right here is the amount of water that's leaking out of the tank, because this represents the rate, but an amount would be the integral of that rate. And because they said from time 0 to time 6, that's why we're integrating from 0 to 6. And then the rest of this you throw into your calculator and you will get choice A. All right, the answer is choice D. Now they want to know which one gives us an underestimate. So we want to make sure that if we're doing the Riemann sums, we want to make sure that our rectangles are underneath the curve. And trapezoids, obviously, we want to make sure those are underneath the curve. So I'm just going to show you just, like for example, a right Riemann sum. So if I was doing a right Riemann sum, I would be going, let's say I was going from 0 to, I don't know, wherever that is. If I go up to the right side of that interval and over, do you see clearly that that rectangle is an over approximation? So let me do another one. If I went like this, over, you can see that that's an over approximation. Okay, so it's definitely not going to be a right Riemann sum. Now let's look at the left Riemann sum. Well, if we're looking at the same initial interval, I would start on the left side, work my way over. That's an under approximation, all right? Let's do the next one. We go here, over, okay, and we can even go further. And you see that all of those are definitely under approximations. Let me clear this out again so that you can see trapezoidal rule. So now trapezoids, we're going to have to draw trapezoids. There we go. Sorry, not the best picture in the world. But you can see that those are under approximations. Okay, 81, the answer is choice B. Now, this is a calculator question. If I were you, listen carefully. I would put this in my Y1. Okay. Your calculator, no, all right, hold on. So let me start again. We're going to put this in my Y1. Now they want points of inflection, which would have to do with the second derivative and a second derivative sign chart. Your calculator will not compute this as a second derivative, but it will give you a graph of the second derivative. So if I were you, I would put this in your Y1, okay? So let me just write that. So in your Y1, you're going to put f prime of x. Then what you're going to do is after that, you're going to, and pause me at any point in time if you want to try it. In your Y2, you're going to hit math 8, which is your end deriv, right? Okay, and then do dx, and in the big box, put vars y, vars enter, enter, so you have y1 in there. And then when it's saying it, what value, just write x equals x, okay? All right. Now, remember I spoke to you, and I hope that you remember this. I don't want to see the graph of what's in my Y1. I just want to see the graph of what's in my Y2 because that technically is the second derivative. So you can turn this off. So you're going to take your cursor. This is why you really should be doing this in your calculator and not just listening to me. Take your cursor, go up to where it's hovering over the equal sign, and hit enter. And what will happen is that black box will turn off because that way you will only see this when you look at your picture. Also, make sure that go to your window and change your x min to 0 and your x max to 2 pi. Otherwise, you're going to get some kind of a wacky picture. Okay? All right, so when I did that, I ended up getting a picture that looked something like this, something like this. Okay, now this is the second derivative picture. Okay, and they want to know how many points of inflection we're going to have. And that would be where your second derivative hits the x-axis, right? So you're going to have 1, 2, 3, 4. And there is your answer. Okay, 82. Let's look at that one. 82, the answer is choice C. All right, so I'm going to kind of do a little bit of process of elimination here. So what I started by doing was I just kind of drew some random pictures. And so if we have A and B for simplicity's sake, right? And let's say our picture looks like that. Okay, and this would be the graph of the function. So I just started with that, and if I look at choice A, it says there's a number C in the open interval from A to B where f of C, in other words, the y value at C, has to be equal to 0. Okay, so they're telling you here essentially that C is going to be inside this, in other words, in between. So if C is somewhere in here, this is saying its y value would have to be 0. Well, that's clearly not the case for my picture. Let's say C is right here. Its y value is all the way up here, not at 0. And this is saying which one must be true. Now, could I have drawn the picture going from A and going down like this? I could have. But it says which one must be true, and I just drew a picture that disproved choice A. So choice A can't be it. So then I looked at choice B, and it says there is a number C in the open interval from A to B. Okay, so once again, let me get my little pointer going here. C would be somewhere in here, and it's saying that its y value would be larger than A's y value, but less than B's y value. Okay, so then I tried to draw a picture that would maybe, potentially, disprove that. So what I did was I went like this. Here's A, here's B, right? C is somewhere in between. What if my picture looked like this? Well, if that's the case, then wouldn't it be the case that f of C, let's say C is right here, f of C is lower than A and B's value? Okay, so that would disprove choice B. So I crossed that out. Okay, I'm going to skip over C. I'll get to that in a minute. We know that that's the right answer. Maybe we don't know why, but we know that that's the right answer. Okay, so then choice D says there is a number C in the open interval from A to B, so again, in between, or in between, depending on which picture we're looking at, where the derivative is equal to 0. Okay, now, if the derivative is equal to 0, that means the function has to have a maximum in between A and B. Well, it doesn't in between A and B. Look at this picture. Well, now, in this picture it does, but this one says which one must be true. And if I look at this picture, I don't have a maximum or a minimum in between A and B. Okay, so therefore, we can eliminate choice D. Now, E, really, if you read through that, that's the mean value theorem. However, mean value theorem, you have to have closed interval there, which this doesn't have. So it wouldn't be choice E. Therefore, it's choice C. Okay, now why is it choice C? Because the extreme value theorem is a theorem that we've used not very often, though, so here we go. And the extreme value theorem states this. If we have a function that's continuous, okay, which is what we have right here, we have a function that's continuous on a closed interval, which is what we've got here. So we have a continuous function on a closed interval, okay? Then the function has to attain a maximum or a minimum at least once in this interval. okay? So, could there be a number c such that the y value at c would be higher than the function at x? Yes, because the mean value theorem states that if you have a function that's continuous on a closed interval, which is what we have, then we would have a maximum or a minimum at least at one point. All right, 83, the answer is choice D. If you look at the question, they are asking what is the value of f prime of 3, but we have f and we have a chart. So my brain automatically goes to mean value theorem. All right, so mean value theorem basically states, remember, f prime in this case of 3 would equal f of, now I'm going to pick the value that's higher than 3 in the chart, which would be 3.1. And then I'm going to pick the value lower than 3 in the chart, which would be 2.8. And then that would be over 3.1 minus 2.8. Okay, so then from here, the rest I think should be pretty easy. We're going to just subtract 48.05 minus 39.2, get that answer, and divide it by this. And you would get choice D. I think it ends up being 29.5, and 29.5 will round to choice D. Okay? All right, let's look at 84. 84, the answer is choice E. Choice E. Okay, so I have a graph of the derivative, and they want to know when the function is decreasing. Well, I'm going to do a derivative sign chart then, because then I can look at where the derivative is negative would be where the function is decreasing. Okay, so remember when we're doing a derivative sign chart from a derivative picture, we look at above and below. So we have changes from above and below, or zeros, in the derivative at 2, 4, and 6. So prior to 2, the derivative is underneath the x-axis, then it's above the x-axis, then it's below again, and then it's above again. Okay, so the function is decreasing where the derivative is negative. Okay, 85's answer, choice D. Cross sections, we are always going to integrate, and in this case we are going from 1 to 4. Those are the bounds that are given. And then remember, when we integrate, basically what we're integrating is the area of a cross section. Since the area of that cross section is a side, the formula, is a square, the formula for that is side squared. So then I am going to integrate from 1 to 4, and the length of that side is going to be top curve down to the bottom curve. So essentially what I'm doing is I'm taking x squared over 10, and I'm subtracting negative x squared over 10 dx. Okay, but I'm going to square this, and the reason, remember, that I'm squaring this is because it's side squared. This is the length of the side squared. And then you just throw that into your calculator, work it all out, and you will get choice D. All right, so this is again one of those must be true type questions. The answer is going to be choice B. Okay, now if you look at this function table of values that you have here, you can see that the function, the y values decrease until you get to 5, and then they increase after that. But you know, there are other x values in between 3 and 7 besides 3, 4, 5, 6, and 7. It could be 3.5, it could be 4.25, it could be 5.00001. Okay, so we have to kind of keep that in mind. So let's look at Roman numeral 1. It says the minimum value of f from 3 to 7 is at 12. Well, it's possible, but so we see that at 3 and at 7, we're going to say this is 3 and this is at 7, that they have the same y value, right? So they're both up at here at 20. Now this is saying the minimum value from 3 to 7 is at 12. Well, maybe not. So like, let's say that this is 5, and we're going to say that that's 12. our function could go like this. Maybe it would come back up, but maybe it would blip down and then go like this. But the blip down is at some decimal value somewhere between 5 and 7 that we're not aware of. So that is possible, so that's not the answer. Okay. Choice 2 is a definite, because if it says f prime of c is equal to 0, then that means if the derivative is equal to 0, that means the function has a maximum or a minimum. And it will have a maximum or a minimum. We're not sure what, we're not sure where, but it will have a maximum or a minimum. So that's a check. Okay, then let's look at Roman numeral 3. It says the derivative is greater than 0. Okay, so if the derivative, that means basically the derivative is positive, right? Which means the function would be increasing between 5 and 7. Well, how about we go back and we look at this picture again? This was my attempt at a sketch of the function, okay? The function is not increasing here. It's decreasing. So this is a possible picture for f of x based upon the information that they gave us. So then you could say then that Roman numeral 3 is not always going to be true either. 87, the answer is C. Very simple. You're just going to do derivative picture. I'm going to do a derivative sign chart. And I'm going from -7 to 7. I'm not really sure where I'm hitting the x-axis, but I'm going to look for changes from below to above the x-axis. So if I look at this one, I see that I start below the x-axis. Then at some place I start going positive, someplace else I start going negative, and at someplace else I start going positive again. And they want to know how many relative maximums or minimums does the function have, okay? And so maximums or minimums occur when you have sign changes in your derivative. So I've got 1, 2, 3 sign changes. Okay, 88, the answer is choice C. Oops. Put my marker on, then I can circle it. There we go. Okay, so the answer for 88 is choice C. Now the big thing here is they're talking about R of T, and they're describing it as the rate at which the water is sprayed. Then if you read the second sentence, it says during a specific time interval, we'll go back to that in a minute, what is the average rate of water flow? So this is the rate of the water, this is the rate of the water. So there's no change, okay? But if they want so in other words, I'm not going from a rate to an amount, which would, signify that we might be doing an integral or a derivative or something like that. But so because we're going from a rate to a rate, we know that the R will be staying the same. However, this word average is the kicker right there. And that word average means average rate of change. I'm sorry, average value theorem. And the average value theorem, if you recall, is an integral from a specific set of points, A to B, okay, of f of x over b minus a. All right, so in this case, they're saying to go from 0 to 4. And in this case, f of x would be represented by r of t. And then we're going to divide by 4 minus 0, or 4. Okay, so then you just put the rest in your calculator, make sure you divide by 4, and your answer is choice C. Okay, the answer for 89 is choice 4, which is, choice D, which is 44. Okay, so they give you an equation for h of x, and they want you to find h prime of 1. So I think the most important thing to do first is to start with h prime. So h prime, I'm going to do product rule. Now, let's just double check. Here is my first term, and here is my second term. So that being said, here is my first term times the derivative of the second term, right here, derivative of that, the 1 disappears, and the g becomes g prime, plus, then we've got the second term times the derivative of the first term. And now all we're going to do is we're going to plug in 1 everywhere I see an x. And we've got the chart up here, and we're going to look at those values and plug them in as we go along. Okay, so h prime of 1. So we're going to have 2 times f of 1, and f of 1 is 3. This will be plus 3. And close those parentheses. Okay, g prime of 1. G prime of 1 is 4. Plus 1 plus g of 4, which is negative 3, times 2 times f prime of 1, which is negative 2. Okay, and when all is said and done, you work that out, you will get the answer of 44. Okay, number 90. 90, the answer is E. Now, one thing you have to remember from pre-calc is when you see that f of g of x, so this is a composition of functions, it's equal to x. But notice if we flip these f and g functions around and we write g of f of x, it's also equal to the same thing. When that happens, then we know that f and g are inverses. So if these are both equal to x, and all that's been changed is the f and the g get flipped around, then we know that f and g are inverses of each other. So now, if I know that f and g are inverses of each other, then I know, for example, if I look at the fact that f of 3 is 8, I had you guys write it as this. 3 would contain the point, I'm sorry, f would contain the point 3 comma 8. Now, if f and g are inverses, then g will contain the point a, 8 rather, comma 3. So therefore, then I know here that g of 8 is 3. So I look through my answer choices and I know it can't be 8 and it can't be, I'm sorry, A, it can't be B, but it could be C, D, or E at this point. All right. So now let's look at the next point that they gave you, which was for f prime. Okay, so for f prime, they told you that the point was 3, comma 9, which means for g prime, that would be 9, comma 3, right? Now remember the formula. So if you look, we found g of 8. Now if we take g prime of 8, try to remember that formula. And that formula is if g and f are inverses, then g prime of 8 will equal 1 over f prime of its x value. Okay? And its x value is going to be 3. Okay? So I'm going to put the 3 right here. And I know f prime of 3. Let me go back here. F prime of 3 is 9. So that's what I'm going to be putting in right there. And then my answer would be choice E. Alrighty, 91. The answer is choice D. Okay, so they're giving you a velocity equation, and they're asking for the total distance traveled by a particle. Now, when we think about total distance, that would be position, right? But now total distance, let's also be very careful. If I were to walk forward, I would cover a certain amount of distance. However, if I were to walk backwards, I am still covering distance. It's just in the negative direction. So when they ask for total distance and give us a velocity equation, take into account that the velocity could potentially be negative. All you physics people, right? In my simple mind, I think of that as walking backwards. So if I want the total distance that's traveled, the easiest way to do that is we are going to, now they say from time 0 to time 4, so from time 0 to time 4, I'm going to take that velocity and I'm going to integrate it because that will give me position. Here's the problem. If I do it as is right now, I'm not taking into account that potentially the velocity between the points or the times from 0 to 4 will shift and become negative. So the way that we can fix that is to just take that velocity and we can put an absolute value in there. And then all is good with the world. So what you're going to do is you're essentially going to, in your calculator, take your y1, and you are going to put in your velocity equation. Okay, so you throw your v of t in there. Then go to your home screen. Okay, and you'll probably want to try this out. So if you go to your home screen, you're going to hit Math 9, right, F and int, and you're going to plug in from 0 to 4. When you go to do the big box and you're doing vars, y vars, before you do that, let's get our absolute value. So our absolute value is if you hit the math button in your calculator, arrow to the right to where it says num, and there it is, number 1. If you hit that first and now do vars, y vars, enter, enter, and the rest of it, you will get that answer. Okay, last question, 92. It is C. Easiest way to do that one? I put this in my y1, and when I did that, I have a picture that looks something like that. Okay, now it did say from 0 to 2, so I stopped kind of right around there, and this reminder is a graph of the derivative. They want to know when we have a maximum value, but let's just deal with the word maximum first. So maximum, minimum, increasing, decreasing, always a first derivative sign chart. So if I look at this, I see that that graph is positive until I get to, I don't know really where that is, and actually, you know, yeah, okay, fine. I'm not really sure where this is, but wherever it is, it doesn't matter. Then it dips below, and then after a certain period of time, it goes back up again. So if I look at this, I have a maximum here, and I have a minimum here, okay? So I know, and let me use my pointer here, that this point right here is corresponding to this value right there, okay? And they want to know at what x value does the function attain a maximum value. It would be right here. Okay, so all you have to do in your calculator is second calc, go to 0, find that point, and you will find out that it is 1.465.